Now to present on principle of thermal break profile systems, relevance to Indian market. I'm inviting our next speaker, Chief Technical Officer, Zak Aluminium, Mr. Rasker, Erik.
So good afternoon again. I'm Erik Rasker, as told. So I'll present you very shortly, the Zak Aluminium, what we are doing. Overview of thermal break systems. The presentation before was already on thermal break, so I'll present rapidly. Relevance for the Indian market, which gives some references to the building code in India. And also because I think to get a good knowledge, and I'll explain it a little bit later, you need a holistic performance, a holistic overview, a holistic energy simulation of a building. And certainly in a country as India, you also have to take into account the cooling. So there I will go a little bit into detail on this one. So Zak Aluminium, it's a family company based in Belgium, and what we do, we develop aluminium systems for the building industry, mainly for the building envelopes, so the outside systems, architecture aluminiums, and we distribute them worldwide, and we work there with local partners that fabricate and install the systems. So it's presented here in the center. We are a virtual company developing the systems and distributing worldwide to fabricators that then install them locally. We are active as well in private markets, so private projects, certainly also in project markets, more relevant for the Indian market, certainly. Worldwide in over 40 countries, sales in more than 70 countries. In India, we're located in Pune with a team of 11 persons. I think today it's already a little bit more. Again, going fast. Recent projects already told before, Magnolias and also the address, which is one of the biggest projects going on for the moment in India. Again, we do not install, we do not fabricate, therefore we have partners worldwide, and that's also one of our baselines, together for better. The quality of the product is not only depending on the system, but also on the fabrication and installation. So we also have an active and very intensive training towards partners. Very important, and I think in the end I come back to that. If you want to position yourself as leader, one of the leaders in thermal break and energy performance, we also have extensive testing institute. I must say one of the largest, I think personally it's the largest private test center in Europe, with all the testing, aging testing, cyclic testing, impact testing, safety testing, but very important, and we're the only one today having this test institute where we can do a holistic simulation of the energy performance of real elements installed in a building. So we have there an in situ laboratory where we really can measure the real performance of systems. We have several PhDs programs running on this cube, Reiner's cube, and you will see in the end some very nice simulations. Okay, thermal break systems. Before it was said, you can go from very low insulated systems. You can have non-insulated. I didn't put the non-insulated systems. One advice, and it's always when you can go to very high insulated system, the only thing you have to take into account is also take an equal insulation level throughout all the house. So continuity in insulation is crucial. So sometimes I say better use everywhere non-insulated than in some spots very high insulated, another spot low insulated. This continuity is the biggest problem in insulation. Not in energy performance, but afterwards in building physics and problems you get with condense, with local building of dirt, etc. So keep it continuous. So whatever level you choose, keep it equidistant for the whole building. So you go from a very low level, you have 2.5, up to a level of 1 watt per square meter. How do we do that? If you go for the first system top, it's the main aspect you work on. It's the conduction. So you put these two polyamide strips in between, and you reduce the level from more than 3.8, which is to 7.8 if you go to standard system to 2.5. And if you see the systems before, it was already presented by the person from Technoform. You put gaskets, you put articles inside the profiles to limit the radiation and also to limit convection. Convection, if you go to the CS77 on top, it's typical convection. You have these hollow strips. Try to create hollow chambers within your profiles. Hollow chambers is the principle also of double glazing. You have a cavity wherein you keep the air positioned immobile, it cannot go from one room to the other. You limit convection and you go to high insulation. So very good values. UF 2.1, I will show afterwards, absolutely perfect for the Indian market. If you see you go higher and higher, you also have to limit the radiation. You have materials which are heating up. Aluminium is very conductive material. It has fantastic properties with regard to that. For isolation, it's a little bit less. So what we do, you have to put materials in between to limit radiation from one side to the other. If you look to CS77HE, also CS86, you will see the gaskets also explained before, which really limit radiation from one